morning all. I, Ghaziabad, Assistant Professor, EC Department, would like to present a topic on the subject sensor and instrumentation. The topic for today's presentation is measurement of position using the Hall effect. Here we use the sensors to measure the position, and that sensor is dependent on the Hall effect. Now, first we need to understand that what is the Hall effect. So, for understanding that, we would like to see that how the Hall effect is working. What happens in Hall effect is we take a Hall strip, and this Hall strip is actually a conducting material strip. Conducting means that it will be carrying a current. So, whenever we take a Hall strip, we used to apply this circuit which consists of a potentiometer, a voltage supply, and then the current is flowing through this conducting strip. So this Hall strip is placed, whenever this Hall strip is placed in a magnetic field, then we can see the Hall effect. Now the condition for placing this Hall strip in a magnetic field is that the magnetic field should be kept transverse to the direction of the current. So the current is flowing in this direction and the magnetic field is here. So we consider that the angle which is formed here is 90 degrees. Whenever this condition occurs, we see a potential difference in the another side of the strip. Either we can call it a potential difference or we can call it a EMF which is generated. Now this EMF generated gives us the Hall effect, and this effect or this type of material when we use as a sensor, then that is known as a Hall sensor. Now, whenever we talk about using the Hall sensor, then we use these type of Hall effect conducting strips. Now, as we see, these Hall effect conducting strips will give a EMF. Now, this EMF is calculated as EH is equivalent to KH into I into B divided by T, where this KH is nothing other than the coefficient, proportionality coefficient, and it is known as Hall effect coefficient. This is the current, this I is the current that is flowing in the conducting strip. This is the magnetic field over which we have placed that conducting strip, and this T represents the thickness of strip. Now these all are the parameters that helps us to get the value of the potential that is generated over the conducting strip. This current will be in amperes, the thickness of strip will be measured in meters, and the magnetic field will be calculated in Weber per meter square. And this KH, which is the Hall effect coefficient, this will be volt meter upon ampere Weber meter square. So here we will get a EMF which is produced. Now what happens? This complete effect, this effect of having a conducting strip in a magnetic field is known as Hall effect, and whenever we will be using this effect to see the position, to measure the position of any material that is being placed in this Hall sensor, near this Hall sensor, then that is known as measuring of position using the Hall effect. Now Hall effect can be measured in the conductors and semiconductors. Without any conducting material, we cannot be using this Hall effect sensors. Also, this Hall effect value or this EMF which is produced over here is dependent upon the densities and the mobility of charge carriers. Mobility of charge carriers in the material. So here we need to understand that what are the materials which are used for this Hall effect. So the key factor for determining any sensitivity of Hall effect sensor is the high electron mobility. And as a result, these are the following materials which are used for making the Hall effect sensors. The first one which is preferred is gallium arsenide, that is GaS. Then we use indium arsenide, INAS, indium phosphide, which is INP, indium antimonide, that is INSB, and graphene. These are the preferred materials which we will be using for making the Hall effect sensors. Now, these Hall effect sensors have different applications. So the applications that we can consider when we are using the Hall effect sensors may have, to calculate the magnetic field, to calculate the current, to calculate the power. But here we are talking about the measurement of position. So either we will be refer the word position or we will refer the word displacement. So to have this displacement measurement, we will be needing a structure like this, where we will be again using a Hall effect element. This Hall effect element is nothing other than the Hall sensor. Then we have a permanent magnetic field. There will be a gap in the magnetic field. This is the structural membrane of the magnetic field. When this Hall effect strip, the Hall effect element is put under this gap, an EMF is produced over the other side of the strip. Now, when we need to measure the position, what we need to do is, we will be taking a ferromagnetic plate, or again we can say a conducting plate, conducting material plate. And we will be changing the position of this conducting plate or a ferromagnetic plate. The position change is known as displacement. Whenever we are displacing the position of this ferromagnetic field either to the inside of the Hall effect sensor or away from the Hall effect sensor, there will be change in this electromagnetic field that is produced, EMF produced. So here also we will say that the potential difference or the EMF is directly proportional to the magnetic field, that is B, and it is also directly proportional to the displacement. Like if we push this ferromagnetic plate towards the magnetic field, then there will be more density in the, more tension in the electric field and magnetic field that has been applied here. So the EMF will change. Similarly, if we move this ferromagnetic plate away from the this Hall effect sensor, then it will have more space for the charge carriers to move. So the current will change, and then the EMF, the potential difference that is being produced will. This is how we measure the position of any ferromagnetic plate or anything that is metallic and conductive, and using the Hall effect sensor. Then we need to discuss about the advantages and disadvantages. So when we talk about the advantages, the Hall sensors are capable of measuring a wide range of magnetic fields. Like we can use different magnetic fields, and definitely the density and everything is dependent upon these magnetic fields only. Right. Then the Hall effect sensors are sensitive to both the magnitude and the orientation of it. This is an important advantage. If we increase the magnitude and the orientation, we can have the better effect, better EMF that is produced, or we can say the potential difference created will be higher. Now, when used as electronic switches, they are less prone to mechanical failures since there is no wear on physical parts. This is an important point. Like here, we can use this Hall effect sensors for position measuring as an electronic switch. When we use this as an electronic switch, there is no mechanical failure. Like initial days, we use the mechanical switches, which may have the mechanical failures, the wear and tear, which will not be here because this will be a push button switches. Then the another advantage is they can also be operated at higher frequencies than the mechanical switches. Because here we can use the semiconductors and conductors both. The disadvantage that the Hall effect faces are the Hall effect switches cannot be used in areas with high external magnetism. Like wherever I'm using an Hall effect switch or Hall effect sensor, the magnetic field which is in the external area should not be very high. Otherwise, it will affect my working of the switch. Second, the Hall sensors can be prone to thermal drift due to changes in the environmental conditions. Like if there is any environmental change, a strong environmental change, then we have a thermal drift, because of which the charge carriers can move. And as we know that it is dependent upon the mobility of the charge carriers, so definitely there may be a problem. Third disadvantage that we need to consider is that all sensors can be prone to time drift over the lifetime of the sensor. Of course, because this is a conducting material whose conductivity will decrease according to the time. So it is having a time drift if we talk about the overall lifetime of the sensor. So this is all about the measurement of position using the Hall effect. This is the reference that I am using for this lecture.